Welcome back to Geology Watch by John. Located along the stunning western coast of North America, it's a place filled with great beauty. Despite the natural beauty that attracts tourists from all over the world, this region hides one of the most dangerous geological formations on the planet. Historically, this area has been the stage for immense geological forces. The most remarkable event was the magnitude 9.0 earthquake on January 26, 1700, which ruptured the entire fault line, causing the coastline to drop by several feet and sending a massive tsunami across the Pacific Ocean, documented in Japan. That historic episode, pieced together by modern science, serves as a global alert about the constant threat represented by the Cascadia Subduction Zone. The Cascadia Subduction Zone is one of the largest and most dangerous faults on Earth. Located beneath the seemingly calm waters of the Pacific Ocean, it stretches for more than 600 miles, or 1,000 kilometers, from Vancouver Island in Canada to Northern California. It's a collision line between tectonic plates, working like a massive geological spring, accumulating tension over the centuries until releasing it in a catastrophic earthquake. Unlike other faults that cause only lateral shifts, Cascadia has the ability to generate vertical displacements of the ocean floor, producing tsunamis with impressive force and speed. The magnitude 9.0 earthquake that occurred in 1700 is only one example of the fault's destructive potential. After the rupture, giant waves formed and crossed the ocean with fury, but the most devastating impact was felt on the North American coast. Experts state that this same fault has been accumulating energy for over 325 years and is primed to unleash an equally strong or even stronger seismic event in the future. Studies indicate that the entire length of the fault has remained locked for centuries, significantly increasing the risk of a new massive earthquake. The states of Washington, Oregon, and Northern California, some of the most populous in the region, are located right in the danger zone. Millions of people live close to the coast, which drastically reduces the response time in case of an earthquake and tsunami. In coastal towns, for example, the population would have less than 30 minutes to evacuate to higher ground after the shaking stops. The situation is worsened by the fact that many older constructions in these areas were not designed to withstand a long-duration tremor, increasing the risk of structural collapse and large-scale loss of life. The impacts of a seismic event of this magnitude are not limited to physical destruction. The region's economy, which includes some of the largest technology and aerospace hubs in the world, would suffer enormous damage. Ports, highways, industrial centers, and factories would be compromised, affecting not only the national supply chain, but also global trade. In addition, there's the risk of secondary disasters, such as landslides in the mountainous terrain and liquefaction in urban areas, further worsening the post-disaster scenario. Despite the constant threats, the Pacific Northwest has made significant progress in prevention over recent decades. It has invested in monitoring technology and early warning systems. A network of high-precision GPS sensors, seismic stations, and satellite data now continuously tracks the movement of tectonic plates. These initiatives, like the Shake Alert system, can provide seconds of warning before the shaking arrives. But the greatest challenge remains, ensuring that all communities are ready to act quickly when the inevitable occurs. With ongoing technological advances, scientists have been able to map, with greater precision, the areas of highest tension buildup along the Cascadia Fault. Using GPS data, seafloor sensors, and advanced computational models, it's now possible to identify critical points that demand greater attention. This detailed analysis is fundamental for creating mitigation strategies that can save thousands of lives. However, even with all this technology, predicting the exact moment of the next rupture is still beyond the reach of current science. This unpredictability makes preparation a top priority. Simulations carried out by experts indicate that if the entire fault segment ruptures, the resulting earthquake could exceed magnitude 9. An event of this scale would not only have local, but also global repercussions. Tsunamis generated by such tremors do not respect borders, and while the most powerful waves would strike North America, the energy could impact coastlines across the Pacific, putting unprepared populations and fragile ecosystems at risk. The constant threat to the coast also compromises marine ecosystems. The sudden change in sea level and the violent churning of the water can destroy delicate intertidal habitats. This not only affects local biodiversity, but directly impacts fishing and tourism communities that depend on these environments to survive. Coastal forests at wetlands, equally important for coastal protection, will be inundated, leaving regions even more vulnerable to future storms. The process of reconstruction after a major earthquake is long and challenging. After a future disaster, the region would require support from the federal government and international organizations. Temporary shelters would need to be built, food distributed, and new infrastructure installed. Even so, many survivors would struggle to resume their lives. The loss of loved ones, homes, and livelihoods would leave deep scars on the population, reinforcing the need for more effective preventative measures. This looming threat has triggered a wave of resilience among Pacific Northwest communities. Periodic drills like the Great Shakeout are held in schools, offices, and neighborhoods, teaching people how to react to earthquake and tsunami alerts. Children learn from an early age to drop, cover, and hold on, and to know their tsunami evacuation routes. These simple exercises make a huge difference when disaster strikes, as knowledge can mean the difference between life and loss. International cooperation has proven essential in this ongoing effort. Researchers from the United States, Canada, and Japan share real-time data, exchange experiences, and contribute to the development of new detection technologies for subduction zones. This joint effort enables a deeper understanding of the Cascadia Fault's behavior and leads to increasingly effective solutions to minimize its impacts. Even though earthquakes can't be prevented, science gives us tools to face them with more preparedness and less suffering. Over the years, the seismic silence along the Cascadia Fault has raised growing concern among experts. The entire region has remained without a major tremor for over 3 centuries, which, according to geologists, doesn't represent safety, but rather a buildup of energy that's waiting to be released. This kind of geological inactivity is often compared to a dormant volcano, quiet on the surface, but capable of unleashing tremendous power when it finally awakens. The absence of significant tremors doesn't reduce the risk. On the contrary, it increases the potential for devastation. Cities like Seattle and Portland, which together are home to millions, are under constant watch by authorities. In addition to their large populations, these cities face serious infrastructure challenges, making them especially vulnerable if a major quake hits. The Cascadia Fault may carry a silent threat, but humanity has the capacity to respond with intelligence, with compassion, and with resilience. If you found this content valuable, be sure to like the video and share it with anyone curious about science, geology, or the hidden forces shaping our world. Subscribe to the channel for more stories like this, always told in a clear and accessible way. Hit the notification bell so you never miss an update, and let us know in the comments what topics you'd like us to cover next. Together, we can transform knowledge into action and build a safer, more informed future. See you in the next video.